welcome to Maths with Bob. Today we're looking at solving trig equations 1, the basics. Well, what is a trig equation? I guess the question comes down to. Well, we can see hopefully that this is the trig equation here. This one here. Okay, that's a trig equation. Sine theta equals 0.5. We need to find some angle whose sine is a half. Now, we can actually find the quick, easy one basically on the calculator. Shift sine 0.5, and it should tell us that it's 30 degrees. Okay, now there's something else which is very important with trig equations, and that is this part here. Okay, this is what's called the domain restriction. You can see here theta between 0 and 2 pi, or if you like, 0 and 360 degrees. That's in radians as it stands. So that is, in fact, a great thing in trig equations, and that is that it doesn't have an infinite number of solutions. We have to stop at a certain number of solutions. In fact, we have to just stop in one revolution, if you could think of it like that. Okay, so we know automatically one solution would be, if you like, 30 degrees, which we know hopefully is pi on 6. So let's actually just write that in. Okay, so we know that one of these solutions is pi on 6, or if you like, 30 degrees. Okay, and we can see here from our special angles result, this angle here, if you look at the opposite on the hypotenuse, you can see here it's a half. The sine of that particular angle, you know, in the top corner there of the set square of 60-30 is actually 30 degrees. Okay, so what is the other angle you can see here? There's another one here. Okay, if you have a quick look here, we have another value here, okay, which is also a solution to where a half equals the sine theta graph. Now, what I normally like to do is just draw up a all stations to central, all stations to central, and put in our rays. This is our theta ray, and this is our, if you like, 180 minus, or in this case, let's do it as a pi minus theta ray. Now, something else while we're here. If the domain is given in radians, we should actually give our solutions in radians. If it's given in degrees, we should give our answers in degrees while we're on this. So, the first one we know is pi on 6. Okay, that's the first one here, and then we come around again, so we get to this one here, which is pi on 6 prior to pi, which is, hopefully we can see here, that that actually is 5 pi on 6. So the solution here is 5 pi on 6. Okay. Are there any other solutions? Well, if you look here, there are a couple, but they're out of our domain, okay? So we don't have to worry about those, basically. So within our domain, we only have two solutions where sine is positive. And you can see here the top half of the sine graph goes up in the first 180 degrees, or pi radians. Okay, so what are our solutions? Well, theta, therefore, theta is equal to, you can see here, just pi on 6 and 5 pi on 6. Okay, well, let's actually now have a look at changing the domain. Okay, here you can see I've actually changed the domain from 0 to 2 pi to 0 to 4 pi, and basically what we have to do here is we actually have to go around twice. So sometimes what I do is actually I draw up the all stations to central, put the rays in, and then just go around twice. Boy, oh boy, that didn't look too good, did it? I go around twice, and basically you can see here you're hitting those rays in about 4 spots. So I might actually try drawing that with a normal pen and see what happens. Okay, so what would happen is we'd have to actually, okay, let's actually try and draw that. Okay, so suppose I actually had, okay, so we know that these are the rays. So this is the pi on 6 ray and the 5 pi on 6 ray. Okay, and we know this is A, S, T, C, hopefully all stations to central. Okay, these are the 4 quadrants. Okay, and we know the sine's positive in the first and second quadrant. So what we normally would do is we'd start, say, let's go another colour pen. Okay, so we'd start at 0. We'd hit it at, okay, we just go around once. Okay, and go around twice. Okay, so you can see here the answers are obviously this one here and this one here. Pi on 6 and 5 pi on 6. And then we just have to add 2 pi to the values to get to this one, and 2 pi to that one. So what are our answers in this case? Okay, So our answers would be what? Theta would be equal to, yes, pi on 6 and 5 pi on 6. Okay, and then we'd have to add on 2 pi. Okay, so that's 12 pi on 6, so that makes it, what, 13 pi on 6. And another 12 on to 5, 17 pi on 6. Okay, and you can see here, these would be our angles, our solutions. You can see here, there'll be, what, pi on 6 here, 5 pi on 6 here. Over here, there'll be, what, 13 pi on 6. And also 17 pi on 6. Okay, and you can see that reddish or pinkish line hits the y equals sine theta graph in 4 spots there. Okay, all right. Now let's see what happens now. Okay, well we're now going to double our angle, so we have a sine 2 theta, and you can see here, well, 2 theta basically goes from 0 to 4 pi if theta is, in fact, the domain restriction is from theta to 2 pi, 0 to 2 pi. Then 2 theta, double the angle, goes from 0 to 4 pi. So what we can do again is we can just draw up all stations to central. Okay, and we know that we've got the same as before. Okay, 5 pi and 6. Okay, and we can go around twice again. Okay, 4 pi. We know the values from before. And this time it's actually 2 theta is equal to these values. Okay, and obviously when we find theta, we have to halve these. So in fact, we know that 2 theta would equal these values as before, pi on 6, 5 pi on 6, 13 pi on 6, and 17 pi on 6. Okay, but because that's 2 theta equals those values, we need to actually now halve them to get what theta is equal to. So what would theta equal? Well, theta obviously would equal half of those values. So that's pi on 12, 5 pi on 12. That's 13 pi on 12. And also 17 pi on 12. And these values you can see here, I can't write them all in because they're getting quite small, but basically I'll just grab one. 17 pi and 12 would be, okay, this x value here. Okay, obviously 13 pi, okay, this value, and so on and so forth. Okay, but anyway, so these are the values, and you can see here the sine 2 theta graph is actually cut by that line in 4 spots. Okay, and remember we have to limit it between 0 and 2 pi. But we normally would double it because we've got 2 theta and then we halve it to drop the values back into the range from 0 to 2 pi. Okay, all right, so let's have a look now at what happens when we have 3 theta. Okay, now 3 theta, we're going to have to go around 3 times because if theta is in the range from 0 to 2 pi, then 3 theta is 0 to 6 pi. And we're going to get 6 solutions. Okay, so what we'd do here is, again, we would draw up our all stations to central, put our pi on 6. Actually, that's getting very close to the end. Okay, so let's just move that across a bit. So, okay. So we then we put in, okay, 5 pi and 6. These are our initial rays where sine is positive. All stations to central. Now we need to now go around 3 times. So we it's going to be a bit of once, twice, thrice. Okay. So you can see here we're going to have quite a few values. So we're going to have what? Let's write down here. Okay. 3 theta is equal to what's that? Pi on 6. 5 pi on 6. Okay, what's that? 13 pi on 6, 17 pi on 6, and then add 12 to these, 25 pi on 6, and then what's that, 12, 29 pi. That's supposed to be 29 pi on 6. Okay, that's 3 theta. So what are our theta values? Well, now you can see we have to divide by 3 because we actually have, that's 3 theta. So theta is now going to give us what? Theta would equal, okay, you can see here. Now 3, so 3, 6 is 18. Okay, well, you can see here. Okay, all right, quite a few. Okay, dot, 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 you can see here up to 29 pi on 18. Okay, so that's those 6 particular values. And again, you can see, okay, this one is actually this value here. Okay, this one here, this one here. Okay, I haven't done them all, you can see here. But you can just divide all those values by 3. And you can see there's going to be 2, 4, 6 solutions. Okay. Well, okay, let's have a look now at sine theta on 2 equals 0.5. Now, you can see here, if theta is between 0 and 2 pi, then theta on 2, well, half of theta, will be between 0 and pi. So let's actually draw this up. Okay, okay, so we know, say all stations to central. Okay, we know our rays are here and here, and we know this one is pi on 6 and 5 pi on 6. Okay, all right. So we are going to we're only going to go from you can see here around this way. So we're only going to go to pi. So we're going to get these values here and here. Okay, so we're going to have a situation where, let's have a look. What do we have? We have theta on 2 is equal to pi on 6 and 5 pi on 6. Okay. Then we just double them, okay, and then we end up getting what? Theta is equal to, okay, double that, 2 pi on 6, so it's pi on 3 and 5 pi on 3. Okay, so you can see here, this is this value here, and this one here is this value here. In fact, perhaps we could actually write them in nearly, so we could probably let's write that in as 5 pi on 3. We can actually nearly write these in. We nearly have enough room here. So pi on 3 and 5 pi on 3. Okay, so you can see here we have that's a domain restriction. So sine theta on 2 is actually only half of a sine wave. You can see there, and the line y equals a half hits the top in 2 spots. Okay, 4, 0 to 2 pi. All right, well, thank you for watching, and bye for now.